Hey friends, I wanted to say hello and give you a little guidance on this Build an Atom virtual lab. So for this, you'll need two things kind of open. If you're doing this from a phone, then you might want to open the Build an Atom instruction sheet and copy this down. Otherwise, once you open this sheet, go to File and then make a copy for yourself. And that's where you can enter your answers. So make your own copy and then you can just share that, get the link, and turn that into like for this assignment when you've completed it. That's absolutely fine. Or you can write it down on paper, take a picture, and turn that in. Either way. So for this simulation, when you hit play, you are going to see like these three different options. So we are going to go to Atom and start there. And oops, I closed out my lab sheet. So just click on that lab sheet to figure out what you're doing. So our first instructions, you can explore this simulation. Now, this used to be a partner activity because we would be doing this in our classroom with only like 10 laptops for all of us. So this is like something that if we were in the class, we would do with a partner, but you're welcome to partner up online. Remember, you can always use this Canvas inbox feature to message other students in your classes. That's totally cool too, if you want to work together. I am great with that. Excuse my cat. You are going to identify the parts of an atom. So what parts go into the center of the atom? That's the nucleus. Please enter those parts there. Make sure you're filling in any questions as you go. So to start, you could just like click, oh, no, maybe not on this simulation. That was a different simulation I'm thinking of. So you can like start adding things in here, putting different parts here. So which things end up, like if I try to put a proton out here, oh, it doesn't work. So where do I have to put that proton in order for it to stay in my atom? Where do I put my neutron for it to stay in my atom? And then the electrons, if I try to put an electron in the nucleus, well, it's not going to go there. So where does that electron in my atom go? Pay attention to those things specifically. So which parts go in the center? That's the nucleus. Most of our atoms have a stable nucleus. So that being said, you can also check this stable, unstable box to see, make sure you're creating a stable nucleus. Remember, we did that last unit with the nuclear stuff. So you're going to create 3 examples that have a stable nucleus and 0 net charge and include your drawing here. So when you do that, right now I have a stable nucleus and my net charge in this little box says 0. If I take this away, oh, that says +1. So if you have a +1 charge, you need more of the blue things. Here we go. If you end up having a minus charge, a negative charge, you have too many blues, so you'll need to take one away. And then you can just like do a little screenshot, go to Control Print Screen if you're on a computer with that, and then paste that into the Draw Your Atom box and write down how many protons, how many neutrons, how many electrons it is, and then which element did you just make. After you've done that for 3 stable atoms that have 0 net charge, then you'll go on to the next page and build these other atoms. So which one has 6 protons, 6 neutrons, and 6 electrons? Well, you're going to have to take these. Wait, so we have 2 protons so far. 3, 4, 5, 6. Okay, 2 neutrons, 3, 4, 5, 6, and then 6 electrons, 3, 4, 5, 6. So I've just made carbon there. So I would go type in carbon, and then which thing determines the element? Well, which one of those that I had 6 of, like if I take away an electron there, is it still carbon? Oh, yeah, it is. If I take away a neutron, is it still carbon? Oh, yeah. If I take away a proton, oh, wait, it's not carbon anymore. It changed into boron. So you can figure out what determines the element for each one of these. Then, which ones of those change which, and there are 2 particles, I'll give you a hint there, change the mass number on your symbol. So the mass number will show right here. So I did take away a proton there, and that would change the mass number. And there's one other one that changes the mass number. Then you're going to build some atom that is stable and has 0 net charge at first, and do the action, see what changes. So this action in the first box is add a proton. So, sorry, I've got carbon that's neutral and it's stable. So let's see what happens if I add a proton. Oh my gosh, it changed. What are my options here? Did it change the element? Did it change the charge? Did it change the mass? And I can go look and say, oh yeah, it changed to nitrogen. Then did it change the charge? Oh yeah, that proton, the charge went to +1. Then the mass, when I added that, remember it was 12 before with 6 protons. When I added another proton, it was 13. So complete that, and then see if you can figure out how this works with the nuclear symbol. Remember, we talked about these last unit, where calcium 40 is a Ca with a 40 on the top, and then the atomic number for calcium, which if you looked it up on a periodic table, the atomic number is 20, then that would go on the bottom. So then we would fill out the rest of this table, figure out how many protons, how many electrons, and how many neutrons it has. That's kind of an extra check yourself bonus to see if you can apply this to what we were doing last unit. But the big parts on here, the main points are this second page of this assignment. So that's what you'll really need to turn in. And you should see a submission button on your assignment and hit submit. And once you have done the Build an Atom virtual lab, you can go on to the Edpuzzle if you want, and you can try this Bohr model, this first quiz here. If you don't get to that today, that's absolutely fine. You'll have some more time. And remember, Fridays are also work time for this. And don't forget, we have office hours. I'm here every day from 1 to 2 in the afternoon. And we're trying to keep Tuesdays and Thursdays focused on physical science questions. So there shouldn't be too many kids from the physics classes jumping in there. All right, well, it was great talking to you. I hope you're having a great day, and good luck on your assignments. I miss you. Bye.